Hello students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in this particular module also we'll continue with the numericals which are based on the concept of transformer, right? So let us start with the first numerical of our module. It says a transformer converts 200 volt AC to 50 volt AC. That means on the input side we are having input voltage as 200 volts and on the output side we are having output voltage equal to 50 volts. Now as you can see, voltage is getting stepped down. So this particular transformer is nothing but step down transformer. The secondary has 50 turns and load across it draws 300 milliampere. Now students, when I say load, then this particular statement is simply related to secondary coil, and the current through load, that means current in the secondary coil, and it is nothing but equal to 300 milliampere. What we are supposed to calculate? Number one, we are supposed to calculate the number of turns in primary. Secondly, we are supposed to calculate current in primary, and lastly we are supposed to calculate the power which is consumed in this particular situation. Now let us analyze this and let us write down the given data. So here on the input side we are having 200 volts, so I can say EP, it is equal to 200 volts. So let's say this is transformer. On the primary side we have updated input voltage as 200 volts. It is converted to 50 volts, so I can say it is EMF across secondary, so I can say ES, it is equal to 50 volts, and again on the secondary side we have updated the same. Now the load which is connected, or rather the secondary coil if I am talking about, it has 50 turns, right? So I can say NS, it is equal to 50, and the load which is connected across secondary, it is drawing a current of 300 milliampere. So I'll be converting milliampere to ampere, right? So what will I get? I'll get IS, it is equal to 300 into 10 raised to power minus 3 amperes. And what we are supposed to find? Here we are supposed to find the number of turns in primary, that is NP, right? And we are supposed to find current in primary, that is IP, right? And then we are supposed to calculate the value of power consumed, that is P, right? Now over here we'll assume transformer as ideal transformer. That means input power will be equal to output power. Now let us write down the formulas that we'll be using. The first formula is nothing but the equation of transformer, that is EP upon ES, it is equal to NP upon NS. Second formula that we'll be using is ES into IS, it is equal to EP into IP, or it is equal to IP into EP, it is equal to IS into ES. And third formula is of power, and it is given by ES into IS or IS into ES, right? Now let us move further. Let us start with the solution. Now first of all we'll be calculating NP. Now we'll be using this particular equation, so I can write EP upon ES, it is equal to NP upon NS. Now I'll rearrange to get the value of NP. So NP, it is equal to EP upon ES into NS, right? Now let us move further. So therefore I can write NP, it is equal to, now we know value of EP. What is value of EP? It is 200 volts. We also know value of ES, it is 50 volts, right? So this will become 200 upon 50, and on cancelling I'll get 1 times and 4 times, right? Now this 4 has to be multiplied by the value of NS. And what is value of NS? The value of NS is 50. So this will become 4 into 50, and finally the value of NP will come out as 200 turns, right? So the number of turns in the primary coil, it is equal to 200. Now let us move further. Let us calculate IP in this situation. Now students, for this I'll be using second relation, and that is nothing but the relation for ideal transformer. So for ideal transformer I can write a relation as IP into EP, it is equal to IS into ES. I want to find IP, so I'll transfer EP on right hand side. So what will I get? I'll get IP, it is equal to IS ES upon EP, right? Now I know the values, so I'll be substituting the values. So therefore I'll get IP, it is equal to, what is value of IS? Value of IS is 300 into 10 raised to power minus 3. Value of ES is 50. So this will become 300 into 10 raised to power minus 3 into 50 upon value of EP is 200, right? So on cancelling I'll get 2 times and 3 times. So this will become 3 into 50 will give me 150. So this will become 150 upon 2, and on cancelling I'll get 75, and this will get multiplied by 10 raised to power minus 3. So finally I'll get IP, it is equal to 75 into 10 raised to power minus 3, which is nothing but equal to 75 milliampere. So current across primary is 75 milliampere. Now let us move further. Let us calculate power. Now for this I'll be using third relation. Power is given by the formula IS into ES, right? Now we know the relation, or rather we know the values of ES and IS, right? What is the value? What is the value of IS? The value of IS is 300 into 10 raised to power minus 3, and value of ES is 50. So let us substitute. So we'll get 300 into 10 raised to power minus 3 into 50. 300 into 50 will give me 15,000, into 10 raised to power minus 3 will give me 15 watts. So in this situation, power which is consumed, it is equal to 15 watts. Now let us move further. Let us start with the second numerical. It says the primary and the secondary coil of transformer are assumed to be ideal, have 20 and 300 turns. So number of turns on secondary are higher. That means it is step-up transformer. If the primary voltage is Vp, it is equal to 10 sine omega t in volts. What is the voltage in the secondary coil? Now let us write down the given data. So here we are having Np, it is equal to 20, and value of Ns, it is equal to 300. Right? Then we are provided with the value of Vp, it is 10 sine omega t in volts, and we are supposed to find the value of Vs. Now let us write down the formula. The formula that we'll be using is Vs upon Vp, it is equal to Ns upon Np. Right? Now let us start with the solution. Now I'll transfer Vp on right hand side. So what will I get? Vs, it is equal to Ns upon Np multiplied by Vp. Now see the given data. We know all the values. So let us substitute. Value of Ns is 300. Value of Np is 20. Right? Value of Vp is 10 sine omega t. And on cancelling, I'll get 15 multiplied by 10 sine omega t, which is equal to 150 sine omega t. Right? So students, in this particular module, we have covered two numericals which are based on the concept of transformer. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.